Hi, this is TheoryStation and I'm John Duggan. This program is Rational Choice Modeling. The series we're in is the Basic Formal Theory Toolkit, and this is installment 12 in the series. So in the previous installment, I talked about, or last couple installments, I talked about the two-dimensional policy choice model. We've really been focusing on, policies and preferences, and we talked about Pareto Optimality. In this installment, I want to push that model a little bit, first by adding some politics to it. So we're going to be talking about the multidimensional model again. But now we're going to add a status quo. And we're going to have two decision makers. We looked at a model like this in the one-dimensional context. So there, the structure that we assumed was a first politician will make some policy proposal, then a second politician chooses between that proposal or a status quo policy. Okay, so they have to approve any proposal by the first guy. And that's what we're going to, we're just going to impose that same structure here, but in this two-dimensional policy world. Okay, so in terms of the model, again, it's this two-dimensional space. We're going to have an ideal point, P, for first politician. And we'll have another politician with ideal point R. And we'll assume a status quo. Well, let me just be clear. Both these guys have Euclidean preferences. So the utility of politician 1 from any policy is just going to be, if I write it out, if I expand it, it's x1 minus p1 squared minus x2 minus p2. Yeah. And then for the second guy, same thing, but using their ideal point instead of the first guy. So, okay. And then we'll have a status quo policy. All right. So if I were going to draw a picture of this, I'll draw an indifference curve for the second guy. The first guy has an ideal point somewhere, and the status quo is somewhere in the space. And we draw it like so. All right, so now we're going to impose this optimality principle on both of these decision makers. Again, we need to figure out what is the approval decision of the second politician for any possible proposal of politician 1. And that's going to work very much like the one-dimensional version of this model. So if the first politician proposes an X that's inside this circle, notice status quo is here, so this circle I've drawn is the indifference curve through the status quo for the second politician. Any policy inside that circle is going to be closer to the second politician's ideal point, and so they're going to choose that instead of the status quo. They will approve anything inside that circle. Any policy outside that circle is going to be further from the ideal point of the second guy than the status quo, and so they're going to reject anything out there. There's still a little bit of ambiguity. What about a policy proposal that's on that circle? So it's the same distance. So the second politician's indifferent between the status quo and that proposal. But we could get this from a deeper analysis, but for now I'm just going to assume, like we did initially in the one-dimensional model, I'm just going to assume that when indifferent, the second politician accepts. So what that means is that, so we figured out the second guy's acceptance decision. Anything on that circle or inside will be accepted, any proposal in that circle. Anything outside will be rejected. So this circle or ball, some people, you would say in math, but this is the acceptance, I'll say region. It's not an acceptance interval anymore, but it's an acceptance region. And so we figured that out. We can think about the decision of politician 1. We impose the optimality principle on that politician. We're going to assume that they understand the incentives of this of the other politician. So they know, politician 1 knows they can only get policies in that acceptance region. So their decision problem is to choose the best thing that will get accepted, and that means the closest thing in this acceptance region to politician 1's ideal point. And that's actually pretty easy to see. If I draw this line between the two ideal points, the closest thing in that acceptance region to politician 1's ideal point is this policy X right here. And it can be informative, so that will be the ideal or the optimal choice of politician 1. Let me just write that down. That's the optimal proposal for politician 1. It can be informative to also draw the indifference curve for politician 1 through that optimal proposal, and it's going to be a circle, and I won't draw the whole circle, but notice that we have this tangency condition. X is on this line, therefore, and we know that line consists of all the Pareto optimal alternatives. So the optimal proposal for politician 1, which is then approved by politician 2, is Pareto optimal. So what we see is that the incentives of these politicians, combined with this optimality principle, they lead to outcomes that are Pareto optimal, which is, normally speaking, we would say that that's a good thing. Again, though, there's a whole range of Pareto optimal outcomes, so I can't say whether that's the best, sort of socially best outcome that's possible, but at least it's Pareto efficient. Notice that just like we did in the one-dimensional model, we can do comparative statics on the status quo here. So if the status quo, say, moved closer to politician 2, that acceptance region would now be given by a smaller circle, and then the optimal choice for politician, that was not good, the optimal choice for politician 1 is going to still be on that line, but it's going to be closer to politician 2's ideal point. When the status quo becomes better for politician 2, it gives them more leverage. They can be more demanding, and politician 1 has to compromise more. They still get something better than the status quo, and it's still Pareto efficient, but now, it's closer to the ideal point of politician 2. Obviously, if we move the ideal point away, then that acceptance region gets bigger, and the optimal proposal gets better for politician 1. So that status quo is kind of controlling sort of the bargaining advantage of one player over the other. Okay, so that's probably enough about that. Let me end by just thinking about non-Euclidean preferences. Suppose we have a decision maker who has indifference curves that are not perfect circles. Okay, so we would call those non-Euclidean preferences. I think it's pretty clear that the assumption of Euclidean preferences is a really strong one. So, it's makes things very easy. It's good for examples, but it's not really, it's not great for a general theory. Well, in this two-dimensional model, we can certainly allow for preferences that are non-Euclidean. So, you could imagine someone with just really strange-looking indifference curves. We usually rule those kinds of curves, indifference curves out, but we could allow for someone who has indifference curves like this. Those are quite reasonable. And there's more formal ways of saying that, but these we would want to allow in a theory of policy choice. And for that matter, we could have someone, another decision maker with indifference curves like this. Those are a little weird looking, but those are still, valid. So, we can, these guys each have ideal points. We can use the same notation as before, P and R. And in particular, we can talk about Pareto optimality in this model. The definition of Pareto optimality is the same as it was. We say a policy X is Pareto optimal if there's no way to change it that makes one person better off without hurting the other. So, for example, this X here, that's not going to be Pareto optimal because we can find a policy that is, it's inside the indifference curve for each guy. So that means we've now moved to a policy where both politicians have higher utility. Well, that means X was not Pareto efficient or not Pareto optimal. Another way of saying this or seeing it geometrically is that if we look at the indifference curves through X, they form this lens, and that lens consists of policies that give both decision makers a strictly higher utility, so X can't be Pareto optimal. All right, what would a Pareto optimal policy look like in this model? Well, it would be a policy where you don't have that lens, so there's a tangency like this one here, or this one here, or this one here. So those are going to be Pareto optimal, and if we connect all of those tangencies, we would get something like this curve here. So instead of a straight line between the ideal points in this model with non-Euclidean preferences, the Pareto optimal set of policies, it's going to be a curve. That's, so this idea of of a tangency carries over from the model with Euclidean preferences. That is kind of a general feature of Pareto optimality. Being on that line between the ideal points, that is an artifact of the Euclidean preference assumption. Again, in this model, if we were to put in a status quo, like this Q, we can think about the model where the first politician makes a proposal, the second politician approves or rejects. The idea of the analysis is completely, it's very much the same. There's going to be an acceptance region. In this case, it's going to be given by, we would look at the indifference curve through the status quo for politician 2, and then everything inside that indifference curve will be approved. And politician 1 just proposes the best thing she can. Now, with non-Euclidean preferences, that may not be the closest thing to her ideal point, and it doesn't look like it is here, but it's you basically just have to look in the feasible set in that approval region for the policy on the highest indifference curve for politician 1. And in this case, it would be this policy here. That would be the optimal proposal. Given the status quo where I've put it, this policy would be the best thing for the first politician to propose. And once again, we see that there's tangency there. The optimal proposal for politician 1 will always be Pareto optimal. So that also is a general feature that carries over to more general preferences. I could go on more about this model. It's a very rich model, but I think that's enough. So in the next installment, I want to sort of swing back now toward the economic side of things. And I want to return to the cost-benefit model and extend that to have 2 decision makers. And we're going to use that to think about what are called public good provision problems. So that's what's coming up in the next one.